Schaefer, and I wanted to give you some quick feedback on your lab. You are so close to really mastering this lab. So I wanted to give you some more direct feedback in hopes that you will go in and fix this lab and submit it for a better grade. So many of you had no problem with the idea that viscosity is a fluid's resistance to flow. And here was a hint for question 2, because some did struggle with the idea that when you heat honey, it is only a physical change. In this case, the viscosity is going to change a little bit. Think about you put your honey in the fridge. How easy is it to pour versus if you microwave it like 5-10 seconds? Remember, we didn't boil this, we just heated this. So we took it through different temperatures. If it were to like boil off or we add something to it, then maybe there's a chemical change. But at this point, we're just looking what happens as we slowly change the temperature. The viscosity lab, how we measured it, there's actually equipment out there that can measure viscosity, which we don't have. Instead, what I asked you to do is an indirect measurement, and you would use this data table. Did we measure viscosity by temperature, or did we measure it by the distance it flowed? Hope you picked that. We picked the distance it flowed. That's the data we're collecting, is the indirect measurement by how far the honey flowed in 30 seconds. Most people did pretty well on the hypothesis, but remember, if the goal is about viscosity, somewhere viscosity needs to be in the hypothesis. So check out if you missed any points on that. Just go in and fix that to use the idea of viscosity. So when you increase the temperature of the honey, then the viscosity or the rate of flow will increase, decrease, or stay the same. Question 5, many of you missed because it was close to that data chart. You need to label the independent and dependent variable. Remember that the dependent variable is the data collected. So one of these is the independent variable, one of these is the dependent variable. All right, then we have the graph. If you have any problems with graphing, please come into Office Helps, and then you can get some extra help. If you don't want to wait for those Office Helps, there is a link on the lab on how to use graphs using the Word, by inserting shapes, by inserting a graph in Word, by using Paint, or there's also one on Excel. So all of those helps are there, but if you're struggling, come in and get help. Here is some of the information I started to work on. Many of you lost points for right here. It says make a key. In this case, we have honey equals whatever shape you use. And you'll see that I didn't put all the data points in, but I did put some of them in. Notice how it's a really small slope. It's not steep. The numbers are only going from 4.4 to 7.2. And so if you're using this graph here, you shouldn't see much of an increase along this chart. And that will help us with our trend line. You're using the data to help you insert a trend line. It's not a connecting of the dots. A trend line means it's the average. So you're just collecting the average. And you're doing that by drawing a line through most of the points or near the points to create an average. And if you look at your data, you know that it grew. So it went 10 points from 0 to 10, it only increased by 0.3 centimeters. And when we go from 10 to 20 points, it's about 6.6 centimeters. So this growth is small. That means that there's no way this trend line can be over 9 centimeters. It has to be between 7.2 and 8.5. Anything more than that, and there's probably not accurate because of how small these jumps are. When you take 7.2, subtract 6.1, you get a pretty small growth there, but look how many temperature points it increased. That was 30 degrees. We didn't do that as much when we get to that question, but you'll see that later. Anyhow, the point is that your trend line goes through those lines. All I did was insert a line. I started before the 0, made sure that it went through or near as many points as I could, and have it going beyond the graph. That's all you need for that, and that gives you your 2 points for that, 1 point for the key. Then you get 1 point for each of these points, 1, 2, 3, 4, 5. So that's 5 points. You don't need to use a different symbol for each trial because there was only one trial. You just need to have one key. If you did, that's okay. You're not going to lose points for that, but that's how you get your points. This is where most of people lose points, is they say they'll go in and restate their hypothesis. My hypothesis was blah, blah, blah. And then you'll say, my data supports or does not support the data. But then you forget to use data in the discussion part. You have to actually use numbers from the data point. So here's your data points. We need to use some of those numbers. We need to use 1 to 2 to 3. You can use more, but at least 2 data points to help us. Here's an example. So if my hypothesis was that as temperature increases, the viscosity increases, I could then say, after graphing it, because I can see that that happens, I can physically see it, my data did support the hypothesis after restating it, and then I need to use some examples. At 0 degrees, the distance traveled was, and then I go back to my data chart, 4.4 centimeters. But at 70 degrees, the distance traveled was 7.2 centimeters. This means that as the temperature increased, the viscosity increased also. That is the pattern we're seeing in the graph when I look at this data, that as the temperature goes up, on that y-axis, the x-axis is also increasing. It's slight, but it's still increasing. So as temperature goes up, viscosity increases also. And we can see that using the data. We can see it on the chart that this is a positive slope. All right, that leads us to that last question, which is what will happen at 80 degrees centimeters, which is only 10 degrees more. Remember, from 40 to 70, that's 30 degrees, and it increased not quite 1. So this is only going up 10 centimeters, but we've drawn our trend line, so we can come out here now and say, oh, look, I think it's going to be right about there, and read the graph. But we can also logic it and know, excuse me, that it can't possibly be above 10, and it's probably, there's no way it's going to be above 9 either. Anyhow, I wanted to go through that with you. Please take the time to fix up that lab and turn it in so that you can get those points, because I believe you understand the concept that you're going through. And now that you look back on it, that you can say, yes, I got it, I understand, and then get all of those points, because I believe it will really, really help you in the further grades. If you have any question, please let me know so that I can help you. Have a great day.